And we did a couple of word problems. Okay, everybody's focused now. We did a couple of word problems on the paper called review sheet. Okay, you guys, I handed this review sheet out ages ago because we did the exponent practice. So this was handed out a long time ago.
Sorry, I got this a while
Okay. All right, so let's look at the word problems. All of you got the sheet. It was handed out forever ago, right? First section of the chapter, because we did this practice, exponent practice. It's all stapled together, but we did that a long time ago. All right, so let's look at the word problems.
Which page?
On the one we were doing yesterday. The one that's called review sheet, chapter 3. And we did A and E already. A and E already. So look down through the rest of those word problems. Which ones do you want to do? We'll move over and do some more on the rest of the page.
H.
But for now, let's look at the review problems. Okay. H. The relationship between intensity at a depth of x feet is given by this equation. You may have actually done this problem, but that's okay. So what is the intensity at a depth of 40 feet? So what do? I have my equation given to me. I have to find I if x is 40. So I'm just going to put 40 in right here. So now I have I over 12 equal to whatever that is, multiplied. Negative 0.0125 times 40. A negative 0.5. All right, now remember, I'm looking for I. I eventually want to have I equals. Can I loop-de-loo? I absolutely can loop-de-loo. What is my base here? 10. So 10 to the negative 0.5 equals I over 12. And then I will be 12 times whatever 10 to the negative 0.5 is. So remember, you have your little caret button. That's how you can raise to a power. So 12 times 10 to the negative 0.5. Did you get 3.795? I already did. All right, is that okay with everybody? Moral of that story, when you have to solve an equation that has one logarithm in it, just one logarithm, think about loop-de-loo. At least think about doing it. You're probably going to do it, but there might be a case or two where you don't. All right, good. Any other word problems there that we need to do? C. What interest rate is necessary to enable an investment to increase from 321 to 765 in 5 years, and the interest is compounded monthly? Now, you have at the bottom of that paper there are two formulas, and then we have these two also. So when you do one of these money problems, you really have to stop and think, which is the right formula to use. So remember, the two on the paper here, FV and PV, are only used when what's happening? Making payments, right? Making payments. Am I making payments in problem C? No. So which am I gonna do? Compounded monthly. Right there. So we want to end up with 765 if we start with 321. I don't know my interest rate, but I know I'm compounded monthly, and I'm doing it for 5 years. Would you agree with that? Now, listen to me. Is my variable an exponent? No. Therefore, you will not use logarithms. We use logarithms when our variable is up here. That's when we use logarithms. If my variable's not up there, I'm not doing logarithms. So what am I doing? Well, first thing, I think I'm going to multiply that and make it 60.
You
Okay.
just plug it in.
What else should I do?
Oh, and now you distribute the 321.
Okay, now, yeah.
Oh, just divide
Okay,
3.
I gotta divide the 321. Now, Jake, we gotta get this straight. You cannot distribute because this is going to the 60th hour. Okay? So no distributing. You do want to divide. All right, so this is what we've got. What are we gonna do? I gotta get R by itself.
So, both sides.
Exactly. We are going to take the 60th root of both sides. That is the only way to get rid of the 60. It's like when you square root to get rid of the squared. We're 60th rooting. Alright, so now we've got the 60th root of 765 over 321 equal to 1 plus r over 12. Now am I getting closer? So let's talk about what we're going to do, and then we'll talk about how we're going to do it on the calculator. So remember, you're solving for r. So we're going to get r by itself, which means we'll subtract 1. So we got the 60th root. We're going to subtract 1.
Times by 12.
And then multiply by 12. Would everybody agree that would get r by itself?
Yeah.
Okay, so let's find the 60th root. Now, if you have an old calculator like mine, so one of these, you are going to, first of all, type 60. Then you're going to go into your math menu and find the button. So I type 60, then I find a button that says X root. Everybody has that button. But you guys with newer calculators, I think you have a little like flashing thing there, you can put 60 in. I can't. I have to type 60, then that button, that is your X root button, and then I'll do 765 divided by 321. So let me catch up here. So X root 765 divided by 321. And then I'll subtract 1 from that, so minus 1, and then times by 12. So I got 0.175. So what interest rate would be necessary? 17.5%. Yeah. So, two things things came out of that problem. One is, your calculator will take any route you want it to take, just use this button right here, okay? The second thing is, just because we're in the logarithm chapter doesn't mean we use logarithms for every problem. We use logarithms when this, or in your PD and FD, if that exponent is the variable, if that's where x is, you need logarithms. Otherwise, don't do it. It's just gonna make it harder. Okay? All right, let's pick one more word problem. Let me see another one in there. F. The number of students infected with the flu is given by this formula. So again, they're giving me a formula. Is that 4 minus t?
Yeah.
Okay. What was the initial number of students infected with the flu? Now, no, it isn't 300. Stop. Guys, if we're talking about the kids infected with the flu at the very beginning, then time is 0. Time 0. T is 0. That is your initial value. That is the y-intercept. That's the beginning of the problem, right now, this instant. And then 1 day later, t will be 1. 2 days later, t is 2. But right now, time's 0. So I'm gonna put a 0 in right here. So basically, I have 300 over 1 plus e to the 4th. So I just type that in. 300 divided by parentheses 1 plus second ln 4. I got 5.396. Now, let's keep in mind, what am I finding? The number of kids. So I'm not going to say 5.396. I'm going to say about 5 kids, right? If you want to round up and say 6, okay. That's how many kids were sick at the beginning. All right. Second question. How many students were infected after 4 days? Well, I'm going to do exactly the same thing, only I'm going to let t be 4. So I'm going to have 300 over 1 plus e to the 0, which is 1. So this is 300 over 2. So 150 kids after 4 days. When will 200 kids be infected? Plug in 200 where?
P.
Exactly, over here. Right, P of T. Now look what's going to happen, boys and girls. 200 equals 300 over 1 plus e to the 4 minus t. Right? I'm going to need logarithms.
Yep.
How do I know I'm going to need logarithms? Because my variable is an exponent. Right? My variable is an exponent. But I'm not going to start with logarithms. Oh, no, 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 no. First, I'm going to move this to the other side. So 200 plus 200 e to the 4 minus t equals 300. Right? Get rid of that denominator. This was the bonus question you all blew. Notice it's on the review sheet now, so it won't be a bonus. You know how to do it. So we'll bring that denominator over. Now let's move that. So 200 e to the 4 minus t equals 100.
Yep.
divide by 200, so e to the 4 minus t equals a half.
Or no, look at the
ln both sides now. Are you keeping up? I'm going to ln. So 4 minus t equals ln 0.5. And remember, you're solving for t. So you can do that one of two ways. You can subtract 4 and divide by a negative, or you could add the t to this side and subtract the ln 0.5 to that side. It doesn't matter. Get t by itself. And then type it in. So 4 minus ln 0.5. I got 4.693. And that is days. So it's perfectly okay to have decimal days. We don't want decimal people.
Can we do the ln.5, put that in a calculator straight away, and then solve after that?
You can, but you can't write it down and round it off because it's going to throw off your answer.
You also
Okay. You can also do intersections, yep. Yep. Yep, if you have access to your graphing calculator, you can do it with graphs, absolutely. Should have gotten the same answer. Okay? All right, let's switch over to the other side. All right, 6 is a very interesting question. Please note that if it's circled, like 3B is circled, it's a calculator problem. If it's not circled, you should be prepared to do it without a calculator. So I'm looking at problem 6, and it says, with regard to this equation, talk to me about domain, range, continuity, increasing or decreasing. This is a blast from the past. Symmetry, abounded, extrema. I am on problem number 6 on the same worksheet. Problem number 6. I'm on the same worksheet that I've been on. I'm just looking at the other side of the page. Problem number 6. Check. I'm on the same sheet I was just looking at.
other side of that.
Okay. Now, in order to answer all of these questions, we should sketch it. All right? So think about your BFFs. Can you remember what the logarithmic function looked like?
Yeah.
Yes.
What did it look like? What did you show me
That
guys?
was 2 asymptotes.
No, it didn't go up and down.
No, it was like
Oh, it was like,
it was like this.
It's like 1 asymptote.
You guys are in sad shape. The logarithmic function looks like that.
yeah, I was thinking.
Yeah, I was
You didn't say
not
that
That's your
either.
logarithmic function.
No, that's not what it was.
Now, again, review. We got an exam we're going to take soon, and we might as well be reviewing this.
BFF.
What does that do to the picture?
What's the left one? Left
Left
one.
one. So, instead of having an asymptote at 0, it's now going to have an asymptote at -1, because you went left. And instead of having a dot at 1, it's now going to have a dot at the origin. Other than that, it's the same picture. So this is the picture. So one of the questions was, does it have any asymptotes?
Yes.
And the answer is yeah, it has one at -1, x equals -1. Do all the BFFs have asymptotes?
No.
No, think of your cubic function, think of your quadratic, but this one does. This one has an asymptote. Okay, can you tell me about the domain of that picture?
Parentheses, negative one to positive
-1 to positive infinity. Notice, no brackets, because -1 is an asymptote, not included, and of course we never include infinity. All right, tell me about the range.
All reals.
All reals, negative infinity to infinity. It goes all the way down and all the way up.
No.
Perfect. Is it continuous? Now
Yeah.
remember what
Yeah,
that
it is.
means.
Yes.
Once I start drawing it, can I draw it?
Yes.
Yep. On its whole domain. Probably, it's a good idea to do it, but if you just said yes, I would give you credit, but come on, we're supposed to be calculus students. All right. Increasing or decreasing?
Increasing.
Increasing on its entire domain. That means the whole thing is going up. Have we looked at BFFs that are both increasing and decreasing?
Yes.
Think about your friend the parabola. Doesn't it start off decreasing and then it
Goes up.
increasing, right?
Yes.
This one is on its whole domain, the entire thing is increasing. Does that have any symmetry?
No.
No. No. When we think of symmetry, we think of like parabolas. Do they have symmetry?
Yep, zero.
Yeah. Y-axis, right?
Symmetry across
Yeah, all
the
real.
Is, this has no symmetry. Bounded.
No.
Bounded means floor and ceiling.
None.
None.
Non-bounded.
Unbounded. None. No bounds at all. Go back to our friend the parabola. He is bounded below because he has a floor. Think of your sine curve. Bounded below and above.
So the cosine.
Extrema. But what we mean by extrema are maximums and minimums, high points and low points.
Infinite, all reals.
We don't have it.
Oh, no.
If you don't have a valley or a hill, you're not gonna have an extrema. Okay? You gotta have a max or a min. End behavior. This is huge.
Zero.
No. End behavior. We have got to get this notation used correctly. So this is our end behavior notation. Now there are a few things that will cause you to get no partial credit. And one of them is not using the correct end behavior notation. So every time you do end behavior, you say the limit as x approaches infinity, the limit as x approaches negative infinity. What happens at the ends of the picture? This one is a little bit tricky because this one does not exist. Why does it not exist?
That's not a one.
Because you can't go to negative infinity because you got an asymptote in the way, right? So there is no left side end behavior. Now, what about the right side? What is happening the farther out I go? Infinity. Very good. Okay, so that was a really good review, especially for your semester exam. That problem.
I have a question. What if there's a horizontal asymptote, like, and like some, like say at like 3 or 4? Would that make it symmetrical? Because you can like cut it down the middle.
No.
Still wouldn't.
Symmetrical is like parabolas, where there's a line of symmetry.
Do you see what I'm saying? Like if you could cut through like the origin, and that would make it symmetrical.
Not really.
Oh, I see what you're saying.
Yeah.
Is it going to be symmetric, so is this piece gonna match up with
Yeah,
this?
yeah.
No,
I mean,
no.
Not with the logarithm. You can probably draw something that way with the logarithm. Okay. Now I lost my train of thought. Okay, look at the rest of the problems and tell me what it looks like we need to talk about on this sheet.
I do.
We're not coming back to this sheet, folks. Today is it. So let's get our questions answered here. What does it look like you can't do?
let's try to do one. Let's do 1A then.
1A,
1A.
Yeah, let's get that one.
1A,
That's probably really
I like that one. I like that one.
we're gonna write an exponential function. So A times B to the X, A times B to the X.
Yeah.
And we know 0, 2, and negative 1. All right, who remembers how to do this?
2 is the A.
2 is A. We know that the initial value is the y-intercept. That's what happens when you put a 0 in here. That goes away, so A would be 2. So y equals 2 b to the x. That's where I am so far. Now what?
Now you plug 3 in.
You plug in 0 to the X.
You plug negative 1 into 1.
Already did that, Jake.
You plug
We
negative
got
into
that one
Plug
covered.
3 into
Oh,
y.
you put negative 1 and.
Plug negative 1
3
into
into the Y,
so
negative
about
1
that.
Yeah.
Better stop.
Now, one thing that sometimes we get confused about is, there's a lot of variables in here, but remember your ordered pair is x and y. So you are plugging in for x and y. All right, so what do we got? 3 halves equals b to the negative first. What is b
1 over b.
to the negative first? What does that mean? 1 over b. So 3 halves equals 1 over b.
Cross multiply.
So 3b equals 2 and b equals 2/3?
Can't you just flip those?
So my answer, y equals 2 times 2/3 to the x. And remember, we never, ever, ever combine these. They are separate numbers. Don't ever put them together. Okay? All right. I think maybe we ought to do B, because I pretty much am sure that's going to be a test question. We're going to write the equation of the logistic function. Now, what does a logistic function look like? This is exponential.
Limit to growth.
Y equals A,
Over
1 plus
b to the
BC to the X.
We have to do that?
Yeah,
Okay, what's up?
okay, so that's what an exponential. You're gonna have to write the equation of an exponential. Right there, we got one. That's what it is. Now, what do we know? We know the initial value is 10. We know the limit to growth is 12, and it contains the point 2, 2. Now notice,
A
there
equals
are 3 variables, A, B, and C, and there are 3 pieces of information. Each piece of information is going to give you something, but you got to do it in the right order, or it's going to be a big mess. So, where does the limit to growth show up
On top.
in the equation?
No.
On top. That's on top. So I know already my equation is 12 over 1 plus BC to the X. Now, what does it mean to be an initial value? What's 0?
Y.
X is 0.
X is 0.
So you cross out.
X is 0. The initial value is the same as the y-intercept. So this is the point 0, 10. So now I can go to here. I can put 10 here and 0 there for X.
You multiply the 1 plus B over.
But I know that C to the zeroth is 1. So 10 equals 12 over 1 plus B. See how all the pieces fall into place? So now we'll multiply over. So 10 plus 10B equals 12. So 10B equals 2 and B equals 1/5.
Yeah.
So now I'm gonna put a 1/5 right here, because that's B. So I've done the initial value, I've done the limit to growth, the only thing left is that point. So here's where I am. So 2 equals 12 over 1 plus 1/5 C squared. Alright, now what?
Let's play on another side.
Bring this over, so 2
Plus.
plus 2/5 C squared equals 12.
And before we
Subtract that 2 over.
Subtract that 2.
Minus 2, so 2/5 C squared equals 10.
Yeah, multiply by 5 times. 25.
So C squared
25.
equals 25 and C
Five.
equals
Talk about a lot of steps.
a lot of steps. GTQ, guaranteed test question. Okay, but again, yes, there are a lot of steps, 3 to be exact, because you're finding 3 variables, but the first one's easy. Limit to growth goes on top, right? Then use your initial value, which is the y-intercept, so plug in 0, and then plug in your other point. All right? Okay, let me see if there's anything else I think is gonna cause issues. I don't know that you guys, I don't know, can you guys figure out
We might as well just do number 4.
2A? Let's look at 2A.
That's actually. Oh, I can't.
All right, so here's the deal. Hey, what kind of dealing is going on here?
He paid me for a little something. I gave him a little something. I gave him a little something. Can you guys do that some other time?
All right, here we go. Here we go. Now, this is the given. So somewhere in there is going to be where we find the answer to the question. Your job is to find the log of 100. Now, the given numbers were 2 and 5. These are made up numbers, base X. Can't do it on your calculator. You can do the arithmetic on your calculator, but you can't get an answer. So, I want you to think about this for a second. Is it possible?
I love that ringtone. He's like a little kid.
Not gonna get an
All right, hang on a second, I'm gonna take this.
A. Wait, Jamie, take
just as my stepdad died a few hours ago. And this is, hi, what's up? It is. Okay. Thank you. Yes, he has. Okay. Did my mom give you my number? Okay. Can I take your, I'm actually teaching a class right now. Can I take your, that's okay. Can I call you back in a little while? Okay. So you are Ryan, and what's your number? Okay. 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 I'll call you back in a little bit. Okay. Bye-bye. I wanted to know about funeral arrangements. I mean, okay, all right, here we go. So, 100 can be broken down into 2s and 5s. Would you agree with that?
Yeah.
So let's do that. Let's break 100 down into 2s and 5s. So how can I get 100?
25 and 4.
So 4 times 25, which would be 2 times 2 and 5 times 5?
Yes.
Now, I'm going to expand this using my properties of logarithms. Since these numbers are being multiplied, they're not exponents. When I break them apart, I am going to add them. Remember that? That's one of your properties of logarithms.
Yeah.
So we took the 100, which was the problem, we broke it up into 2s and 5s because that's what the given was. 2 times 2 times 5 times 5. When you take the logarithm of a product, you can split it up into a sum. What's the log of 2 according to the given?
0.12.
0.12. And that one's 0.12.
0.56.
0.56.
So
0.56. So the answer is whatever all those are added up together. 1.36. So the answer to the problem is 1.36. Is that okay? All right. All right, let's see if there's another one in that section. You want to do D or C? C? All right, same given. This time, we are finding the log of the 4th root of 2x. Okay, now just hang on a second. 4th root of 2x. What are 4th roots? 4th roots are what power?
1 to 4.
Negative 4.
No, no, no,
1/4.
not negative 4.
1 over
1/2.
Yes.
1/4, right? Radicals are fractional exponents. So this is 2x to the 1/4. What happens when you take the logarithm of something to a power? Where can I put the power?
In the front of the log front.
Out in front. Okay. What are you doing?
I turned in my blood drive.
No, those go to Mrs. Whistler. And are you gonna get the rest of your Kleenex or not? Vance, you want the rest of your Kleenex or not?
No. We just interrupt our class.
Now, these guys right here are being multiplied, which means when I expand it, it will be expanded as an addition. Now notice I put parentheses because the 1/4 goes with both. Would you agree with that?
Sure does. So what does it look like to us separate?
Then it would be like the 4 through the 2 times x.
Okay.
The 4 through goes with both of them. Now, the easy part is right here. I know that is 0.12. Can somebody tell me what that is? That wasn't in my given. What do I do with that?
Cancel that out.
Nope, don't cancel it out. Leave it.
Actually, you kind of do.
Cancel, because they're two the same.
Not totally cancel
It's
it.
not even totally, but you
Put a one there.
Put a one where?
Is where the top X is.
Yeah.
No.
Like, in between, like, the plus signs.
The 1/6 is 1. Now,
Oh my gosh, I knew that was over.
for those of you that are baffled by that concept, I want you to think for a second, if we had, the log of 10. If I said, what's the log of 10?
10.
Log.
Oh, 1.
10 to the x.
10 to the x equals 10, wouldn't you say that's 1?
Yes,
Yeah.
When these two match,
It's always one.
it's 1, every time. So it didn't matter that it was an x, they match, so it's 1. So now I can do that arithmetic and get the answer to the problem. 0.28. So, those problems are a little odd. They weren't in the homework, but the properties of logarithms were in the homework, and that's how you do these problems. You recognize you can split this up into a sum. You can pull the exponent off in front. Put your feet on the floor. All right, look it over. What else? That was number 2 we just did. What else do you see?
Or 4 would be mine. I would get caught up
Which one?
on all of them.
Pick one from 4.
Let's just, I mean,
B. D. 4.
B and D. B and D.
Yeah, give me the D.
All right, so D says negative 27. Guys, I don't want to talk over you. Please, just stop. So, negative 27 to the 2/3. Now, don't be flipping anything. There's no negative exponent, but there is a fractional exponent, which means I'm going to have a radical. Under its negative 27, it's a cube root squared. Now, under normal circumstances, I'd be freaking out with a negative under there, but not when it's a cube root. What's the cube root of negative 27? Negative 3. But I'm squaring it, so the answer is 9. The answer is
So it's only an I if it's only either.
It's only i's if it's a square root. Guys, what's negative 3 times negative 3 times negative 3?
27.
Negative 27. The cube root of a negative is a negative.
And if it was a 4,
You can't do a square root or a fourth root or one of those. You can't do the even root of a negative. All right, and then you wanted to do D. Well, this one's easy compared to some of them that we've done. What happens here?
X to the 4th on top.
X to the 4th on the top.
And then Y to the 7th on the bottom.
These come down, total of 7, and that problem's finished. What's the answer answer is 7A.
One.
Two.
Seven is two.
7 squared is 49.
70x.
What's the answer to 7B?
7B?
7B.
No, 5, it's 5.
7B. B.
Oh, B?
D or E? B. It's some weird answer.
Radical.
B is 5.
Yeah, B's 5. You can't me.
Oh.
Wait, how?
Oh, yeah. 2 to
C
6.
is 4.
Which is this?
D is 5. E.
10.
Zero.
0. Remember, if you are finding the log of 1, that says 10 to the x equals 1. 10 to the x equals 1.
Zero, yeah.
And that would have to be 0.
Next one's 2.
How about F?
2.
2. How about
1 7. 1 7. No, negative 7. Negative 7. Negative 7.
Negative 7.
Negative 7.
Oh,
Negative 1 7.
yeah.
Negative 1 7.
All right,
Negative 1 7.
we have some argument.
Negative 1 7.
It's negative 1 7. Stop it.
We finally settled on something, but let's see if we're right. It's ln 1 over e.
Yeah, no, negative 1 7.
Right? So if I loop-de-loo this, it would look like this. Would you agree with me?
Yes.
Now, whatever my exponent is, it's going to be negative. Would everyone agree with that? What do I do with this square root? What exponent is a square root? 1/2. So this is 1 over e to the 7th to the 1/2.
Oh, no, that is true because.
Square root of x is x to the 1/2.
Yeah.
Okay? So the square root of something is that thing to the 1/2 power. Doesn't matter what the thing is.
So it's 1 to the 14?
No. What's 7 times a half?
Oh, 7 halves.
And since it's 1 over,
Negative 7 halves.
negative 7 halves.
Oh. That's tricky. Well, I can definitely get that one wrong. Yeah,
That one's really hard.
was that the quiz?
And how about h? What is the
3
answer
halves.
to h?
3 halves. I don't know. X, 5x. Negative 2 over 3. Negative 2/3.
It's not 3 tenths. I said 3 tenths.
Negative 2/3.
It can't be a negative. It's not
Negative 1 half.
Why is it negative? Is it 1 over?
No.
It's just 1 half. 2 over 3.
2
No.
over 3.
Oh,
Dang it, 2 over 3. Guys, the square root of 25 is,
Oh, I was wondering.
25 is 25 with 1/3.
Can't keep using
And 25 is 5 squared. So your exponent is 2/3. All right, so your job for the next time I see you is to look at the back of that paper that you just texted
Say it out loud.
Just because football's out, does
and
not mean
bring
you
me
can't.
some questions from the back.
Yeah.